Section 9.4, Example 3 on page 714, we have you can use the Greek capital letter sigma to indicate a sum. With it, you use limits to indicate how many terms you are adding. Limits are the least and greatest values of n in the series. You write the limits below and above the letter sigma to indicate the least and greatest values of n. For example, you can write the series 3 squared plus 4 squared plus 5 squared plus all the way to 108 squared as the sum of n squared from n equals 3 to n equals 108. So the upper limit is where the series ends with n equals 108. The lower limit is where the series begins with n equals 3. And this right here is going to be your explicit formula for each term, which we can see will be n squared. For an infinite series, summation notation shows infinity as the upper limit. To find the number of terms in a series written in summation form, subtract the lower limit from the upper limit and add 1. The number of terms in the series above is 108 minus 3 plus 1, which equals 106. Example 3 says, what is summation notation for the series? 7 plus 11 plus 15 plus all the way till we get plus 203 plus 207. We can rewrite our series and look for a common difference. From 7 to 11, we add 4. 11 to 15, we add 4. And 203 to 207, we also add 4. So our common difference here is going to be 4. We are also given an initial term, a sub 1, of 7. We can use our general formula for an arithmetic sequence, a sub n equals a sub 1 plus n minus 1 times d, to find an explicit formula for the sequence. A sub 1 is 7, d is 4. We can distribute the 4 into the n minus 1 to get 4n minus 4. 4 times n is 4, 4 times negative 1 is negative 4, and then we can combine like terms. 7 and negative 4 will give us positive 3. So we have 4n plus 3 equals a sub n. This is an explicit formula for our sequence. Before we move on to whether there are 51 or 50 total terms, we can already notice that only A and B have 4n plus 3 as the explicit formula in the multiple choice answers, so we can discard option C and D. Now, using our explicit formula, we know that 207 is going to be our final term, so we can plug this in for a sub n and solve for n. This gives us 207 equals 4n plus 3. We can subtract 3 from both sides. 3 minus 3 is a 0 pair. 207 minus 3 gives us 204. And now we're left with 204 equals 4 times n. If we divide both sides by 4, 4 over 4 becomes 1, and we're left with just n on the right-hand side. 204 divided by 4 gives us 51. That means that 207 is our 51st term, and therefore we would choose option A. Option A goes from 1 to 51 and has the explicit formula for n plus 3. Be careful not to choose option B. It looks very similar. The only difference is that it says we have 50 terms, which is incorrect. The work for this problem is written out on the next slide. And now I would like you to try number 4. Write each arithmetic series in summation notation. We have 5 plus 8 plus 11 plus all the way until we get 38.